So, all right, I can see we've got Jim Carver here, and he is just about ready to give his talk. Let me give an quick introduction for him, and then we can have our next session. So, Jim Carver is the Strategic Business Development Manager at PSA Certified at ARM Limited. He has over 30 years of experience in the electronics industry, joined the PSA Certified team back in 2020, and is responsible for building and strengthening ecosystem relationships with silicon and software partners, as well as with the cloud ecosystem. Now, Jim's role is crucial as PSA Certified moves toward its goal of making hardware-based security readily accessible for IoT product developers. So Jim's talk is how can PSA Certified and RT-Thread ensure the proliferation of secure IoT devices? All right, you all set, Jim?
I am all set. I think
All
I'm
right.
all set. Hang on.
Oh yeah, not a problem. Nice to meet you.
I'm having technical difficulties.
Okay, not a problem. That's one of the fun things with doing live sessions. So there's always some little glitch or hiccup. So no problem. Everyone here is patient, and we understand. So.
By George, I think I figured it out. Okay, sorry about that.
Have a great session. Oh, not a problem. Okay, I'm gonna leave it to you now.
Thank you very much. Thanks everybody for your time, and thanks for your patience putting up with my finger checks here. So, I'm Jim Carver. I'm on the PSA Certified team, and the whole goal of PSA Certified is to increase the security of the Internet of Things. We're really laser focused on the IoT. So what is PSA Certified all about? It's designed as a certification scheme with some of the major players in security in the industry. So we have it's a total of 7 companies that got together, and we started looking at, how can we make the IoT secure? And so we partnered up with many of the leading security labs in the industry, like AppPlus, BrightSight, CAICT, UL, Riskier, ECSec. We also have TrustCB as our certification body. And we all came together and looked at this problem of security in the IoT and developed the program of PSA Certified. So it's designed as a way that we can go through and actually secure the Internet of Things. So it's a global partnership. It's designed to be a very collaborative ecosystem. And it's all about overcoming the security challenges that everybody faces. So I'm sure, we've got some great talented developers on the call today. The challenges, that I work with a lot of different companies, and they're experts in their individual fields. But security is kind of something that's being forced on them as they deploy connected devices. But they're experts in motor control, glucose monitoring, all the different things that differentiate your company. Security is kind of a foundational issue, but it's definitely something that you have to pay attention to in the Internet of Things. You're connecting your devices to the cloud or through radios, and that exposes them to bad actors. So when you look at all the different things that are happening out in the market, like 5,400 attacks a month on IoT devices, this is pretty crazy. You look at the financial losses that businesses are incurring when they're hacked, and it's I have been doing security for about 12 years now, and when I first started this, the common complaint I got back from customers was, well, security's hard, it's going to cost me money, and my house hasn't burned down, so why do I need to buy insurance? Well, guess what? Houses are burning. But it's still not trivial. Security is challenging. It's a whole new set of expertise that you have to learn. It's something that it's going to impact your BOM somewhat, because you're going to have to, you really need to select parts that are designed to implement secure solutions. You have to have some expertise in security. But at the end of the day, you have business challenges that you have to plan for. And finally, your consumer challenges when you go to market. How do you How do you educate your consumers? And then, of course, you have development challenges. So all of this combines to make security something that unfortunately is still frequently overlooked. We recently did a PSA security survey through looking at over 600 leaders in the embedded industry, and we got some pretty startling responses. The reality is that security is still not commonplace. It's a lot of customers are not developing secure products properly. There's a lot of concern about fragmentation in markets, in regulations and standards. And even among people who think that they're doing security well, for instance, the fact that only 47% of the respondents actually do threat modeling is a bit worrisome, because at the end of the day, if you're not starting with fundamental threat modeling, you're not designing security. And PSA is designed as an approach that can scale. So PSA is built around our 10 certified security goals. So things like attestation. A device needs to be able to attest to its authenticity and its security capabilities. We have to be able to do fundamental things like secure boot, because if you can't validate the integrity and authenticity of the code that you're running, you're already in trouble. We need to implement things like isolation. So you want your application isolated from your root of trust. The reason for that, of course, is that if your application gets compromised, your secrets that are stored in your root of trust are still not compromised. We have to have things like secure firmware updates and anti-rollback. Anti-rollback is super important and often overlooked, because at the end of the day, if you deploy a patch for a security vulnerability, once it's identified, if bad actors can spoof your devices into rolling back to an older and vulnerable version of firmware, they win. We have to have things like unique device identification. All too often in this industry, people cut corners and do things like sharing common AES keys across multiple products. And this is just an invitation to hacking, because what you've done is you've created a highly scalable attack. When you have unique identification per device, the hackers, now it becomes it's a burden to them. They can't attack one and access many. They attack one, they only access that single device. We have to be able to manage things like secure life cycles, secure storage, so that your keys are appropriately stored. And we have to use, good industry standard crypto practices. And so the PSA Certified Framework is designed as a complete offering. So we offer, for instance, reference threat models that you can, for people that are not familiar with threat modeling, you can take one of our reference threat models. You can find one that's close to your product and go through the analysis and develop your own threat models. We have tools to help you architect your solution and implement your solution. So in the previous call, Robert mentioned TFM. Trusted Firmware for Cortex-M is great, because it basically abstracts away all the security complexity away from you, the developer, and just provides you a standardized set of PSA functional APIs. And at the end of the day, you can actually take your end product through PSA certification. This is really important, because now you can demonstrate to your stakeholders and your customers that you have followed best security practices, and you have PSA certification from an independent security lab to show that you've done your work right. That's really important. Self-certification can be something that doesn't build a lot of trust in the marketplace. So, PSA is designed to be at the heart of these of connected devices. So PSA is laser focused on this thing called the root of trust. And so when you think about a a chain of trust that goes between your device all the way up to the cloud applications and user interfaces where you're consuming and presenting your IoT data to your end customers. In that chain of trust, your device's root of trust is the anchor for that chain. And so it's the essential elements within the device that provide the fundamental security. So for instance, you can have great transport security using Wi-Fi, but if you're not protecting your keys, you don't have security. You have encryption, but you don't have security and you don't have trust. And PSA has been designed as, if you will, a layer cake. So there's 3 different components to PSA certification. So at the very bottom, we have the chip level or silicon certification. This is the certification that a piece of silicon meets the requirements for PSA certified. On top of your silicon, you now run your system software. So an RTOS like RT-Thread has been certified by PSA as a level 1 certified piece of system software. And then finally, at the device level, this is where you demonstrate that you're properly using the services provided by your system software and your chip root of trust. And now you can have a device that's PSA certified. So this creates this very unique proposition for developers. You have all of these different aspects of a design that you have to worry about if you want to develop a secure device. And at the end of the day, this can create a lot of time, consume a lot of time, and create a lot of frustration and barriers like a long time to market. And we want to make that simple. We want to demystify and remove the friction from the security ecosystem. So by having all of these interoperable, interlocking pieces of the chain available for you to use, you can much more readily develop secure products and deploy them. And best of all, you can take your end product through PSA certification itself and provide that assurance out to your customers. There's a lot of momentum in PSA certification. These numbers aren't even accurate because we had 3 new devices certified just last week. We're well over 80 now. So, all of the major chip vendors such as Nuvoton and ST have PSA certified devices. And so the great news is that you can choose different silicon based on your unique application needs. There's different types of system software that's available, including RT-Thread. So you can pick the system software that makes most sense to you. And we've actually have a growing number of OEMs like Flextronics. We have Aero Electronics has a number of different reference designs that are PSA certified. Sigma Delta Technologies has different modules that are available. And so all this combines to create great momentum within the ecosystem. We're also doing a lot of industry collaborations. So for instance, when you design a product and certify it to PSA level 1, you have direct mapping of through your certification to ETSI, NIST, UK security requirements or security standards, so like NIST and ETSI. Also, a number of other partners that are doing higher level, so system level certifications like UL, the IOXT Alliance, and CSIP through global platforms. They recognize the certifications from PSA as being fundamental to their certifications. So basically what we're doing is we're creating a reusable and extensible certification that allows you to take your entire system through higher level certifications. Also, interestingly enough, the insurance market has become very interested in this because the insurance market, they have a tough time because of all the issues with cybersecurity now. This is creating huge risks for the insurers. So when they provide your company for business insurance, they're going to start asking, how did you design your security and what is your proof point? And so, for instance, Munich Re is already recognizing PSA certification as an important risk mitigation that'll affect your business insurance when you're deploying connected products out in the marketplace. So let's take a real world case of how you would actually create a end product that can go through PSA certification. It's really pretty simple. PSA certified, like I mentioned before, it's built like a layer cake. You have there's a PSA questionnaire that you fill out. You submit it to one of our accredited security labs, and they will do the evaluation of your security questionnaire, and ultimately they'll generate a laboratory report, which will go to TrustCB. And TrustCB actually issues the PSA certification. They're a certification body. So for you, it's pretty simple. The first step is to select a PSA certified chip. So for instance, Robert mentioned a couple of different families from Nuvoton that are already PSA certified. There's a number of different devices from ST Micro that are also PSA certified. So you pick a PSA certified piece of silicon, and then you run RT-Thread on top of it. That's pretty simple. The great thing here is now, instead of having to answer the chip level questions and the system software questions, those certifications are immediately reusable by you. So you use those products and build your device using the underlying security components. And then you only have to fill out the device portion of the questionnaire. You go to the lab approves you. You now have a PSA certified product. And then that's also recognized by companies like UL and the IOXT Alliance. And so this is a great way for you to go out and develop, not just develop a secure product, but take that assurance out to the marketplace that you've done your job. And this is really important because now you have the you can make the claim that your design has been evaluated by an independent security lab, and these are labs that are very, very well recognized in the industry. And so this is great value. So when you look at the certification, if you want to take a piece of silicon that's not PSA certified and a piece of system software that's not PSA certified, you have to answer all of these questions. You have to answer the 8 chip questions, which means you have to have pretty intimate knowledge of that chip's architecture and how its root of trust is implemented. You have 18 more pretty comprehensive questions about the system software that you have to answer. And then there's the additional 16 questions that you have to answer on the device level portion of the questionnaire. By reusing a certified chip like ST or Nuvoton and a certified system software like RT-Thread, you only have to answer those 16 questions. And that's really important because those 16 questions are where your area of expertise is. And they're pretty straightforward. None of this is rocket science. And so this reusability is an important factor in selecting, PSA certified silicon and system software. So it gives you a lot of great benefits for development. By selecting a PSA certified chip and system software, that you're choosing components that have been evaluated by these independent labs. So this gives you an assurance that they actually comply to best security practices. By using these certified components, you're also going to reduce your time to market for secure products. certified components. Again, it's a higher level of assurance for security, and they're known to work together. And it gives you the least friction to take your product to market with a certification. So this gives you laboratory-backed evidence that your product security is well designed. It's not like, yeah, I'm secure. Well, how do you know you're secure? I said so. Well, that's not exactly reassuring to your customers. So this gives assurance to your customers. It also lowers your risk and liability. Let's be real. It's not a matter of if your product is, immune to hacking. With enough time and effort, almost anything can be hacked. But by going through PSA certification, in the event that there is a vulnerability exposed on your product after it's been in the market for some time, because of course this threat environment is always changing, you can go out, you have a defensible solution that not only did you design your product well, but it complied to security best practices at the time it was designed. And at the end of the day, this gives you a dramatically reduced window of liability if there's, if you will, a fuss about your product being breached sometime down the road. Where to find us? We have our own website, psacertified.org. You can find us on social media. Lots of different great resources on the PSA website, how to design your products, a lot of white papers on security, white papers from our products. And you're welcome to contact me, jim.carver@arm.com. And with that, I want to thank everybody for your time. Hopefully I was able to maybe get us a little bit closer back on track here. But at the end of the day, it's something that we're really eager to help you with. If you've got questions, contact me. I'll jump out of presentation mode and see if there's any questions in the chat now.
Thank you for the presentation very much. If you'd like, I can look through the chat for you. If you want to be able to just answer the questions, we can do a little Q&A that way. It's completely up to you if you want to pull them yourself, though. All right, so let's see here. I can see here we had a couple of questions that came up while you were giving your talk. The first one was, what will happen if different devices have unique identification, but all of them or most of them have the same root of trust, certificate, and keys?
Well, they don't. If you're using public key cryptography, every device has its own unique public-private key pair. And so this is something that's part of a best practice for security design. Ideally, use public key cryptography in some very constrained devices. You may want to use pre-shared keys, but that pre-shared key has to be unique per device. At the end of the day, if you're sharing keys between devices, what you're doing is you're creating a scalable attack for bad actors, because they can get a sample of your device, maybe break in through a JTAG port or some other, find some vulnerability in a laboratory to find that key that's shared across devices. And now they're very happy guys at this point, because now they can go out and launch scalable remote attacks on your devices because they know your encryption keys. So they can spoof these, they can create spoof devices, they can create counterfeit devices if somebody wants to copy your product. They can spoof your devices and connecting into their services so they can extract data from your devices. They're just, you've created a hacker's dream. So that's, and no product with a shared single key will ever get through PSA certification.
Excellent. Thank you for answering that question for our audience. We also have a couple of other ones here. I see, let's see here, where they go. Oh, here we go. So one of the attendees was wondering if if we design our device around ARM solutions, do they have to certify their device for ARM PSA?
No, PSA is there's no requirement for PSA certification. PSA certified is for companies that care about security and want to go to market with evidence that they've done their work correctly.
All right, excellent. Perfect. Thank you very much. I know even in my own consulting, when I'm working with IoT customers, I encourage them to do the PSA certified, even though it's not required, because it's a good sanity check that they're following best practices. So,
well, yeah, and I tell you, it's really interesting how often during a PSA evaluation, vulnerabilities are found by the labs.
oh,
And
I
so
bet.
this is really important because you know you've done your work, but you're only looking at it with one pair of eyes. It's often very useful, especially in something as abstract as security, to have that extra set of eyes on the work that was done. And it's a lot more. It's very beneficial to find and fix these vulnerabilities before you deploy your product out in the field.
Exactly. Exactly. Yeah, the cost once you deploy it to have to, handle privacy issues, the PR, the and
Yeah.
mini nightmare for any company. So like you mentioned earlier, where you said, yeah, people complain that it's expensive to do it. It's far more expensive to recover from it on the back end than to just do it right
Well,
the first time.
exactly.
So, um, let's see here. Okay, so here's a question. I think this is a pretty simple one. In which markets, regions is PSA certified required for silicon chips? I think you've kind of answered this probably, but maybe there's a region where it is required. I'm not sure.
It's not required in any region. What you will see is as different security standards are rolled out, that we will see you will by de facto have to meet you won't have to meet PSA per se, but you'll have to meet those regulations, and PSA will be evidence that you meet those regulations. So for instance, in the US, there's a new NIST standard that's being developed right now that will be required for any product that's sold to the federal government or purchased with federal money. And so PSA is a convenient way of showing that you meet that NIST standard because there's a direct mapping to that standard that's in development to PSA certified. And so
Gotcha.
if you care about the federal government, you will meet that. But what ends up happening is large enterprise customers typically will also follow the federal government's lead, and they'll start requiring it as well. And it's great to see identifiable security standards. One of the challenges we had, 10 years ago was there was not identifiable security standards that a buyer could put into an RFQ. Today, that's changed. And so as your customers become more aware, they're going to start putting things like, I want NIST compliance in their RFQ. And if you have PSA certified, you can say, yes, I have it. And here's my lab backed evidence that I meet this standard.
Perfect. Thank you very much. I think we have one other question here that I currently see in the chat, and then we will discuss actually another giveaways for the comment group. So, all right. So I can see here one of them. This question is from Anders. He says, "How much insight do you need at PSA to certify an application or a device?" So I think he's curious about that certification process.
So the certification process is pretty straightforward. The good news is if you're using a certified chip and you're using certified system software, by reusing those certifications, you don't have to have deep inside knowledge of the chip and the system software, which is not going to be your area of expertise. The device level portion of the questionnaire is going to be aspects about the application. How are you using the system how are you using the system software? For instance, at the application level, you're not storing a different set of keys and just using them. So it's going to be aspects of the design that you're going to be very familiar with, and you'll be able to address. On psacertified.org, you can find the questionnaire and download it and take a look at it. It's pretty straightforward. And we also have, you can also submit questions through our website. We're always eager to help customers learn more about PSA and help them through the certification process. It is for people that have never gone through a certification, it can be a little intimidating, but it is It's an effort well rewarded when you've done it.
Well, perfect. We greatly appreciate you taking the time to give the presentation and answer our questions. And I can certainly, let the attendees know there's great information up there on the PSA website. So there's, go check that out, download. I mean, there's all kinds of fun model specs and examples and stuff like that. So definitely check that out. And thanks a lot, Jim, for answering our questions and being here with us this morning. So.
Thanks a lot. You guys have a great day. Thank you for inviting me, and thanks to all the attendees for your time today. Bye-bye.